Hello students, welcome to day 43 of 99% in 99 days in your 10th board examinations, right? So students, now we are going to study today very important and interesting topic, that is carbon and its compounds. We'll be studying about nomenclature, soaps and detergents. Okay, so now students, soaps and detergents are something that we use every day in our daily life, right? But hardly we think about knowing how exactly a soap and a detergent works, right? And what is the need of having a detergent when we already have soap, right? We can use soap to clean the washing the things and all. Then why detergents were made? What were the limitations of soap? What are the limitations of detergents, right? These are something which is like we should know because we are using them in our everyday life, right? And one very interesting thing that we are going to cover today is nomenclature, right? This is really interesting if we know all the rules. So students, if you are finding our efforts, if you are getting benefited from what we are teaching you in the YouTube sessions, so please let us know by showing your love through the comments. Let us know whether you are finding these lectures interesting or not, whether it is helping you or not. So please let us know, do not hesitate. This really motivates us also. And when we see your participation, we are really thrilled about these lectures, right? So students, please, it's a request from my side, if you enjoy these lectures, then please let us know in the comment section. Okay, now let's get started here. The first one here is your nomenclature of carbon compounds. Okay, so there are total 7 to 8 rules that I'll be telling you. After that, we are going to solve 2 examples and to clarify all these rules. Okay, so first one is identify the longest carbon chain. So you need to identify the longest carbon chain. Now what do you mean by longest carbon chain? Longest carbon chain means the carbons should be continuously attached. Okay, there should not be any branching or in your longest chain. Like for example, if I have a like this one system, okay, now if I see, this can be one chain, okay, where I have all the 4 carbons continuously. I can have this as one chain, okay, where I have all the 5 carbons continuously. So now if I talk like which is the longest carbon chain, this is the longest carbon chain. So whenever a compound is given, the first thing you need to do is to identify the longest carbon chain in that particular compound. Okay, next is number the chain. Okay, now you have to give numbers to that chain, like carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. You have to number the chain, but there are certain rules while numbering the chain. What are those rules? The first rule is the substituents get the lowest possible numbers. Okay, if there is a tie, prioritize the functional groups with higher precedence. Okay, now when you are going to number it, okay, I'll give you an example. Suppose I have like this. Okay, so now this is the main chain of the carbon. I can find the longest carbon chain is 4 carbon chain. Now I can number it 1, 2, 3 and 4, or I can number it 1, 2, 3 and 4, right? So which is the correct method, whether 1, 2, 3, 4 is correct or 1, 2, 3, 4 is correct. Now this you can identify. The rule here is the carbon which contains the substituent, okay, the carbon which contains the substituent should get the lowest number. Okay, the carbon which contains the substituent should get the lowest number. Okay, so it can be like if you are numbering from this side, it is the second carbon, and if you are numbering from this side, it is the third carbon, right? So I can easily see that if I number from this side, the carbon which contains the substituent is getting the lowest number, right? You are getting 2 on this particular carbon. So that is why I can say that this is the correct way of numbering and not this one, right? So we can erase this one. Okay, so the correct numbering of the carbon will be in this way: 1, 2, 3 and 4. Okay, now let us go to the next rule. Identify and name the substituent. So once you have find out the longest carbon chain and you have identified, you have numbered the carbon chain, now you have to identify the substituent's name. Okay, so substituents are used in the prefix. Okay, so in your name, the first part of the name should be about the substituents. So substituents are named like methyl if you have CH3 group, ethyl you have CH3 CH2 group, propyl if you have this group, means 1 carbon is methyl, 2 carbon is ethyl, 3 carbon is propyl. Now if the same substituent appears multiple times, use prefixes like di, tri, tetra or etc. Okay, so here I'll give you an example. Okay, suppose this is a carbon chain. Okay, I'm not writing the H. I think you can balance this one. 1 second. Okay, now I want to find the longest carbon chain. So you can see 1, 2, 3, this is also possible, and 1, 2, 3, this is also possible. So any one I can take. And if I number in this way also on the second carbon, it is a substituent. If I number it in this way also on the second carbon, it is a substituent. So now the substituent is present on which carbon? Second carbon, right? And what is this substituent? It has one carbon, and the name of the substituent is methyl group. So I can write like 2. 2 represents what? Substituent is present on the second carbon, methyl. Okay, 2 methyl. Then we have propane. Okay, 2 methyl propane. Clear? So this is how you can number this particular compound. Now similarly, you can use di, tri or tetra as a prefixes. Now for example, if I have like this, see, now as you can see, this is the longest carbon chain. Okay, 4 carbon chain, and I have the same substituent on second carbon also, third carbon also. So what you will do, first you will write the position 2, 3. Now you want to write methyl 2 times. Instead of that, we will write 2, 3 dimethyl. Okay, next what is the number of carbon? Bute, right? For 4 carbons we use the word bute, and then ANE. Okay, so now next, arrange the substituents alphabetical order. Okay, so if you have more than one substituent, here we got 2 substituents are same, right? If there are other substituents which are not like same substituents, then you should give priority based on the alphabetical order. The substituents which has comes first in according to the alphabetical order should come first in the name as well. Okay, so we'll do examples, it will be clear. Now if functional group is present, okay, functional group is present, these are the different functional groups. Okay, what are functional groups? They determine the suffix of the compound. Okay, so prefix is given by the substituents and suffix is given by the functional groups, right? So if the if it is a pure alkane, then the name will end with ANE. Okay, and if it is a alkene, then the name will end with ENE, and if it is a alkyne, you will end with YNE. Now you know alkane means single bond, alkene means double bond, alkyne means triple bond. If you have an alcohol group, if OH group is there, then the name will end with OL, and if you have an aldehyde group, name will end with AL. If you have C double bond O group, name will end with ONE, and if you have a carboxylic group, that is COOH group, the name will end with OIC acid. Okay, so what is the order of the functional group? So first carboxylic acid, then aldehyde, then ketone, then alcohols, alkenes, alkynes and alkanes. Okay. Okay. Now coming to if double bond or triple bond is present, you have to mention the position of the double bond and triple bond. Okay, these all rules will be clear once we solve examples. Okay, so this is 2 examples I have given you. So remember, prefix should be substituent's name alphabetical order, then root name you have to use based on the parent chain, and suffix you have to use based on the functional group. Now root name, for root name you should remember, if 1 carbon is there, then the root is meth. For 2 carbon the root is eth. For 3 carbon it is prop. Okay, then you have methane, ethane, like this. Okay, next for 4 carbon you have butane. For 5 carbon it is pentane. For 6 carbon it is hexane. Okay, these are the roots name. Now let us see here. If I see this particular chain, you have 1, 2, 3, 4 and 5 carbon, right? 1, 2, 3, 4 and 5 carbon. Now on the second carbon you have methyl group, and on the 4th carbon you have methyl group. So now what I can say, second and 4th I have methyl group. So I told you, if the 2 substituents are same, then we have to use the substituent di, right? So I can write like this, 2, 4, okay, dimethyl, 2, 4 dimethyl pentane. Okay, 2, 4 dimethyl pentane. Next we have another, you can see 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can get 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so now here you can see 6, 7 and 8. So another chain can be 1, 2, 3, 4 and 5, but that is smaller chain, right? We have already got the longest chain. Now question may arise, you should number in this way or you should number in this way. So if you number in this way, you will get methyl here, okay, and you will get ethyl here, right? But again, which is the correct one? See, according to the substituents rule, we know that ethyl should be written first because it is E is coming first then M, right? So E should get the lowest number or ethyl should get the lowest number. So that is why we have numbered in this way. Okay, so what I will get? 3 ethyl, okay, 3 ethyl, then 6 methyl, okay, and octane. 3 methyl, 6 ethyl, octal. 3 ethyl, 6 methyl, octane. Okay, so why we didn't number from this side? Because if you put 3 here, then you have to use 3 methyl. Okay, but remember, when there's a conflict between the substituents, you should follow alphabetical order. The one which comes alphabetically first should get the least number. Okay, fine. Now let us go to hydrocarbons, their classification. So hydrocarbons are of two types. One is saturated and unsaturated. Saturated means alkanes, that means they have only between carbon carbon there is single bond, okay, and unsaturated means between carbon carbon there can be double bond or there can be triple bond. Okay, now alkenes are those where in the carbon carbon you have double bond, and alkynes are those where you have triple bond. Okay, and aromatic compounds are like benzenes. Okay, now there is a general formula for alkanes, that is CnH2n plus 2. Okay, and alkenes it is CnH2n, and alkynes it is CnH2n minus 2. Okay, clear? Fine. Now coming to, okay, so students, here I want to introduce you to something called as DSAT, that is Diksha Scholastic Aptitude Test. Now students, you all are in 10th class, and this after the 10th exams are over, you have to take a very critical decision regarding your career, right? So in this decision, it is always good if you take some expert advice, right? So to help you with this, the DSAT is there, where you get a 60-minute lecture, and after the 60-minute lecture you have a test. Okay, and once you write this test and it will be evaluated, then you will be having a one-on-one mentorship with an expert, okay, who will be guiding you by seeing your performance in the test. They will be guiding you what is your strength, what is your weakness, and which career is the right choice for you. Okay, so this will be really helpful to choose the best career for you. So please do not delay, go to the description section, you can find the registration link, click on the registration link and register for the DSAT. Okay, fine. Now coming to types, okay, that we have already seen, types of hydrocarbon, that is saturated and unsaturated. So in saturated we have carbon carbon single bond, okay, and the general formula is CnH2n plus 2. Okay, so for example, if I take C1, okay, then what will be the value of H? CH4. C2, then it will be H6, right? 2 2s are 4 plus 2, 6. C3, H8. Okay, now similarly, if you have unsaturated carbons, it is CC double bond, or it can also be C triple bond. Okay, now here the name is alkenes and this one is alkynes. Okay, now alkenes, if you see CnH2n, okay, so if I put C1, so for you need at least 2 carbons for alkenes, so you need C2H4, then C3H6, C4H8. Okay, and here the name will be CnH2n minus 2. Okay, so if I took C2, okay, then it will be H2, and if I take C3, okay, 3 2s are 6 minus 2, H4. Okay, I can show you the structure of this one, C3H4. Okay, so you can have like this, here 1 H will come and here 3 H will come. Okay, this is C3H4. Understood? So alkenes and alkynes, saturated and unsaturated. Okay, next coming to how to draw the structures of these ethene, ethyne, how should you draw the structure? What's the trick for that? So the step number 1 is first connect all the carbon atoms together with a single bond. Okay, so for example, I gave you a structure like C4 and H8. Okay, C4H8 is given to you. How will you draw the structure? So let us do with this. First connect all the carbon atoms together with a single bond. So we have 4 carbon atoms, so I'll connect it with a single bond. Next, then use the hydrogen atoms to satisfy the remaining valencies of the carbon, as carbon forms 4 bonds to its tetravalency. Okay, so we will try to, so we have here each carbon should have 4 bonds, right? So we will be putting the hydrogens here. So 1, 2, 3, 4, 5, 6, 7 and 8, right? But now you see the bond is not satisfied, right? So if the number of available hydrogens is less than what is required, satisfy the remaining valency by using double or triple bond. Okay, so what I'll do is, in this case, when you fill the hydrogen, first try to fill the terminal hydrogens. Okay, so you got here CH2 and we need one more bond here, there is no more H. So what will I do? I'll connect this with double bond. Okay, so now you see the valency is satisfied, 1, 2, 3, 4, for all the carbons it is satisfied. Okay, let us try another one, students. Let us do like C3H8. Okay, C3H8. So let me put all the 3 carbons, then we have 4 valencies, put it like this and fill it with hydrogen. 1, 2, 3, 4, 5, 6, 7 and 8, right? This is also done. 8 already it is there. Okay, let us try one more option. Let me try like C5H8. Okay, C5H8. Let us try this one. You have 5 carbon, 1, 2, 3, 4 and 5. Then all the valencies you fill up here. Okay, H8 is there, so we have 1, 2, 3, 4, 5, 6, 7 and 8, right? There is no more H to satisfy the valency. So what I'll do, so I told you first you should think about the terminal carbon, right? So there is one H, so I will use that one H in the terminal carbon, right? Now I can erase this all things and I need to satisfy the valency here. Okay, so I can use like this. Okay, CH, you can see this is a triple bond, here CH2, CH2 and CH3. Okay, done, fine. Next, coming to the chemical properties of carbon. So the first reaction of carbon is combustion reaction. So carbon compounds burn in the presence of air to produce carbon dioxide and water and release heat and light. Okay, so this is called as combustion reaction. Every compound of carbon, when you burn it, you will get carbon dioxide and water. So let me take you an example. If I take methane, CH4, okay, one second, CH4 plus O2, okay, will give me CO2 plus water, okay, and also heat is produced. So if heat is produced in the reaction, then what we call it? It is a exothermic reaction. So remember, all the combustion reactions are exothermic reactions. Okay, so now if I want to balance it, you have H4 is there, so I will make it H4. Now you have oxygen 4, right? I'll make it 2O2. Clear? It is balanced now. This is combustion reaction. Okay, so now see, there is something very important regarding the combustion reaction. Now saturated hydrocarbons means carbon with single bond, burn in the air with a blue and a non-sooty flame, while unsaturated hydrocarbons burn with yellow and a sooty flame. Okay, so unsaturated carbons require more energy or require more amount of oxygen. Okay, so that is why if more amount of oxygen is not present, you will find generally the unsaturated carbons will burn with yellow and a sooty flame. Sooty flame means in the flame there will be black particles. Okay, now where you can commonly observe this? So you can observe this in the gas stove. So one second. Okay, so you can observe here that gas stove at home has inlets for sufficient supply of oxygen, and hence the mixture burns with giving a clean blue flame. But at times if the inlet gets blocked, the fuel remains unburnt and hence the bottom part of the cooking vessels get blackened. This can be asked as a question, okay, why the cooking vessels get blackened at the end or at the bottom. So that is because sometimes when the gas inlet, okay, is blocked, we do not get sufficient oxygen, so the fuel that you are using will not be able to burn completely, and as a result of which you will get black sooty flame, okay. Next reaction is oxidation reaction, okay. So here carbon compounds such as alcohols are converted to carboxylic acid in presence of suitable oxidizing agents like KMnO4 or acidic potassium dichromate, okay. So here one reaction of oxygen, if I show you, CH3OH, okay, what is this? Methanol, right? The word root is meth, okay, methane, and OL, alcohol functional group, so suffix is OL. Now if you treat it with alkaline KMnO4, okay, then what you will get? CH3, okay, not like this, it converts into carboxylic acid, okay. So you have HCOOH. One second. Yeah. Okay, so this is what? Acid. Now suppose for example you take ethanol, the most common reactant that is converted is ethanol. If you react it with alkaline KMnO4, okay, you will get CH3COOH, okay, fine. Now what is an oxidizing agent? So the thing which adds, so you can see alkaline KMnO4, what it is doing in this reaction, it is adding oxygen. So if you see in this compound there was only one oxygen, right? Now in the product you see there are two oxygen. So alkaline KMnO4 is adding oxygen to this one, right? So that is why it is behaving as an oxidizing agent, okay. So substances which are capable of adding oxygen to others are known as oxidizing agent, okay. Now for example you have alkaline potassium permanganate, okay, alkaline potassium permanganate and acidified potassium dichromate solution act as oxidizing agent in many chemical reactions, okay. So generally you have alkaline KMnO4 and another is this one, that is potassium dichromate. So it is K2Cr2O7, okay, this is potassium dichromate formula. So you can use either KMnO4 or K2Cr2O7 to convert alcohols to acids, okay. Next type of reaction is addition reaction. So in addition reaction what happens? During addition reaction the unsaturated hydrocarbons, unsaturated means double bond and triple bond, right? On addition of hydrogen in the presence of catalyst such as palladium or nickel give saturated hydrocarbons, okay. So unsaturated hydrocarbons can be converted to saturated hydrocarbons by the addition of hydrogen in the presence of catalyst, okay. So now catalyst, what is their role? These are the substances that cause a reaction to occur or proceed at a different rate without affecting the reaction. So generally catalyst, what they do, they increases the speed of the reaction, increase the generally, okay, speed of the reaction, okay. So now here also I'll show you one reaction. Suppose we have for example ethene, okay, CH2 double bond CH2, if you add hydrogen in presence of palladium, that is a catalyst, you will get CH2 and you have one H and one H, right? This H is added and the double bond is converted to single bond, okay. Now here there is something very important. This reaction is extensively used in the hydrogenation of vegetable oils containing long unsaturated carbon chains using a nickel catalyst, okay. So long unsaturated chains, the vegetable oils, okay, contain long unsaturated chains. Now if you add hydrogen to that, okay, then you get, it is also called as the hydrogenation of vegetable oils. Vegetable oils have long unsaturated carbon chains while animal fats have saturated carbon chains, okay. So when you add hydrogen we get ghee, okay, we get the vegetable ghee that you get oil when you get saturated, when you add hydrogen and you convert it into saturated carbons we get ghee, okay. So next is your chemical properties. Next one is substitution reaction. So all of you know Substitution reactions are the reactions in which one type of the atom or a group of atom replaces the another atom in a compound. Okay, so sorry, here example, if you see, if you have CH4, okay, and you treat chlorine in presence of H nu, okay, chlorine in presence of H nu, then what will happen? One of the hydrogen is replaced with chlorine. So what I'll get? CH, H and Cl, okay, and you have one, this one Cl and one H will be, now see, here one chlorine came, one chlorine is remaining, and this one H has come out, and that will form HCl, okay. Next is ethanol and ethanoic acid, okay, these are two important components, so we will be learning about some properties of ethanol and ethanoic acid. So if you see, ethanol is commonly known as alcohol. It is the second member of the alcohol series. So what is the first member? CH3OH. Now if you remember homologous series, the next member will be what? CH3OH, and you need to add a CH2 group here, right? Now properties of ethanol is a colorless liquid, okay, its boiling point, and it is soluble in water, okay. Next, coming to the uses of ethanol, it is used in alcoholic drinks, it is used as medicines, okay, in cough syrups and all, it is used in petrol in some countries, then it is used as a solvent, okay, 2 to 3 uses you should remember. Okay, next coming to harmful effects of ethanol. So it has like slows down the metabolic process in the body, it affects the central nervous system, and there's a lack of coordination and confusion. Okay, you have seen generally people when they take alcohols, okay, they do not behave properly, right? What is the reason for that? The reason for that is when they take alcohol, it affects the central nervous system, and your coordination with your body, your actions is collapsed, right? So that is why people generally cannot walk properly, right? You might have seen there, you may take it in a very funny way in movies and all, you have seen many times, but yes, remember please, alcohols are very, very dangerous to your health, okay. So students, now what happens, this drinking alcohols has become like something which people take as to become cool or to become more trendy, they take alcohols, right? Even the young students, young people who are like just 18, 19 years or even younger to that, take alcohols just for fashion, just for trend, okay. But students, please remember, this is never good for your health, okay. So please keep yourself or avoid yourself from taking alcohols and all, that is really not required. To become cool or to become trendy, you do not have to follow any wrong practices, okay. So please make sure that you do not use alcohols at all, okay. These are not healthy, these are not required. Without alcohols also, life is very, very simple, very happy and very happening as well, okay. So that was a message from my side, and I hope that all of you will remember this, and those who students who are promising me that they will never use alcohol, you need to comment down here, okay, fine. Next is reactions of ethanol. First is the reaction with sodium metal, okay. So alcohols react with sodium metal to produce sodium ethoxide and hydrogen gas. So this reaction we have studied also in the like chapter, which one? That is your metals and non-metals, okay. We'll do it again. So ethanol, if you see, CH3 CH2OH, okay, it will react with sodium metal to give you what? This OH part will go out and it is replaced with Na, okay. So I'll get CH3 CH2ONa plus H2 gas. This hydrogen will form H2 gas, right? 1 second. Okay. Next, dehydration reaction. So reaction of ethanol with excess of concentrated sulfuric acid acting as a dehydrating agent at 443 results in the dehydration of ethanol, okay, leading to the formation of ethene. Now how can I show that reaction? So you can see here, if you have ethanol, okay, that is 1 second, okay, CH3 okay, let me draw with bonds so that we can see which bond is breaking, which bond is forming, okay. So chemical reactions is all about bond formation and bond cleavage, okay. So you have like this. Now if you use concentrated H2SO4, okay, that means that will give you acid. So in this case what happens, okay, I'll draw it in another way. This side I'll keep H, this side OH. So what happens when you put this acidic H plus, this group, okay, this is removed, or it undergoes what? Dehydration. Okay, now if it undergoes dehydration, we'll find a double bond here. Okay, and this one will form ethene. Okay, clear? So this is the reaction for that one. Okay, next one we will see, we'll go for ethanoic acid. Okay, so the common name of ethanoic acid is acetic acid, and it also belongs to the carboxylic acid family. The molecular formula is CH3COOH. This is also the second member of the alcohol acidic group. So if you see, the first one is what? You have H, C double bond OH. This is the first member. Now I'll add a CH2 group here. Okay, so what I'll get here? CH3. Okay, so this is what? This is your ethanoic acid. Okay, it is also called as acetic acid. Next, if we want to see the properties of ethanoic acid, so it is very simple. It is a colorless liquid. Okay, ethanoic acid is a colorless liquid. Its boiling point of ethanoic acid is 391 Kelvin. Here, this is important. This is also known as glacial acetic acid because it freezes during winter in cold climate. Okay, so you should remember, this can be asked as an MCQ question. Ethanoic acid is also called as glacial acetic acid. Okay, next, the melting point of pure ethanoic acid is 290 Kelvin, and it is also soluble in water. This melting point temperatures do not you have to remember. Okay, no need to remember these terms. Next, what are the uses? So there are different uses. Vinegar, I hope many of you would have heard it. It is used in your home, right? It is a very sour liquid and it contains at least 5 to 8% of acetic acid or ethanoic acid. Okay. Next, vinegar is used as a preservative. Then it is used for the preparation of dyes, plastics and pharmaceuticals. It is also used in the rubber and latex industries, and it is also used in the preparation of esters. What are esters? Esters are flavorful compounds. Okay. You can find certain certain food items, certain bakery items or certain perfumes have a very fruity smell, right? And that fruity smell is due to the presence of esters. Okay, fine. Now coming to the reactions. So the first reaction that we are going to study is esterification. So in esterification, what happens? Ethanoic acid, okay, ethanoic acid reacts with alcohols, okay, to give what? To give esters plus water. Okay, I hope you are noting down with me. So now let us see one example of esterification reaction. So I will take ethanoic acid, CH3, this is ethanoic acid, okay, plus I am taking methanol. Okay, one second. Okay. Okay, then in this case what will happen? You see, this water will be removed out. Okay, if this water removes, then what we will get? We will get a ester formation. So what we will take? CH3, C double bond O, then we have O, and then we have CH3 plus water. Okay, and this is called as ester. You can see this functional group, this is called as ester group. Okay. Next one is reaction with a base. So this is an acid, and when a base and acid will react, all of you know what we will get? Salt and water, right? So what we will get? Ethanoic acid, okay, plus base gives salt plus water. Okay, so now we have like this CH3 COOH plus base is, you have, I'll take any base, let me take NaOH, right? So what will happen? This H will come out, it will react with this OH and will give you water, and this Na will be replaced with, so this hydrogen will be replaced with H. So I will get CH3 C double bond O ONA plus H2O. Okay. Reaction with carbonates and hydrogen carbonates. Okay, here the products we get is salt plus CO2 and plus H2O. Okay, so I'll give you a reaction for this one. So if you have ethanoic acid, so CH3 COOH, okay, plus carbonates means what? Suppose I take Na2CO3, this is carbonate, right? So this one will give you first the salt, so I will get here CH3 COONA, okay, then you will get CO2 plus H2O. Okay, the same reaction with bicarbonates also you will get the same product. Okay, so these are the different reactions of ethanoic acid. Clear? Next, if we see very important topic, soaps and detergents. Okay, this is something which we use everyday life, so we should be knowing the chemistry behind the soaps and the detergents, right? So what is soap? So soaps are sodium or potassium salt of long chain carboxylic acid which has cleansing properties in water. Okay, so soaps are what type of acid, what type of functional group is present? Carboxylic acids, and the salt, sodium or the potassium salt of carboxylic acid is called as soap, right? Next, soaps are basic in nature because they are the salt of strong base and weak acid. Okay, so you can take one example. Suppose I'll just taking randomly C7H. Okay, let me take like this. Yeah, suppose I have CH3 COOH, okay, plus NaOH. So what will I get here? I'll get CH3COO minus Na plus, right? So now this is what? It is a salt of strong base and a weak acid, right? So in soap what happens? This part doesn't contain only one carbon, it is a very big group like C10, some H22, like this, some very big group is attached, and the sodium salt of such type of groups is nothing but salt. Now because this salt has a strong acid and a weak base, strong base and a weak acid, we call it as it is all generally basic in nature. So if it is basic in nature, it will convert what? It will convert red litmus to blue, right? Now examples are sodium palmitate. You can see how many carbons are there, C15H31COONA. So how this salt must have formed? You have C15H31 C double bond O NOH. So this acid must be present, right? Plus NaOH is there. Okay, so this one will react with C15H31 COONA plus water. Okay, so this is what? Salt of, this is a strong base and every organic acid is a weak acid. Okay, so that is why this is basic in nature. Clear? Okay, next coming to how do we prepare soap. So just now we understood soaps are prepared by heating the vegetable oil or animal fat. So vegetable oils contain what? Carboxylic acids, right? So carboxylic acids are present with sodium hydroxide solution. So fat or oil you can take NaOH, you will get soap and glycerol. Now this process of preparation of soap is called as saponification reaction. This is also an important question. What is saponification reaction? Okay. Next we have structure of the soap. So now the soap molecules have two ends. One end is the hydrocarbon chain which is water repellent, whereas the other end is the ionic part which is water soluble. Now if I just showed you like this, right, C17H31 COO minus Na plus, right? So this part of the soap, okay, it is what? Ionic part, and this one is water loving part. Okay, this is what? This is plain hydrocarbon, this is water repelling. Okay, Okay, this is water repelling. So this is hydrophobic or hydrophilic, and this is hydrophobic. Okay, this is hydrophilic and this is hydrophobic. So now what happens when soap is dissolved in water, it forms a group of many molecules known as micelles. Okay, this is important when you dissolve the soap. Okay, so there are so many such particles. These particles collect together and form a structure called as micelles. Okay, so I'll show you the structure in detail. So you can see this is the structure of soap. Okay, this is the structure of soap where you can see the carbon chain. This is sodium stearate soap. Carbon chain is there and COO minus Na plus, right? This is the hydrophobic part and this is hydrophilic. Okay, this is hydrophilic. Okay, this is hydrophobic. Now what happens when you dissolve? Okay, soap is represented, this big chain is represented like this. Okay, this is the head and this is the tail. So when you dissolve this one, what happens? This ionic part is water attracting, like so this faces the water molecules, and the tail part is towards the inside of the structure, and we get a structure like this called as micelle. Okay, so you can see here the clusters of molecules in which the hydrophobic tails are in the interior of the cluster and the ionic ends are on the surface of the cluster are called as micelles. Okay, so what will happen? These particles will come together, okay, and form a circular structure where the head is towards the water because it is hydrophilic. Philic means the word you love something. Okay, hydrophilic means the part which loves water. Hydrophobic means the word which does not love water, so that remains away from the water, and this one remains towards the water. Okay, clear? Okay, so that is what micelles. Now how do we use them to clean a substance? That is very, very important, and this question can be asked in the examination, so you should know how to present the answer. Okay, you should learn this answer properly. Okay, so first step is when soap is dissolved in water, it is a colloidal suspension. Okay, so it is not completely soluble. You can see whenever you dissolve soap in water, the solution becomes little foggy, right? It is like little not clear solution you won't get. Okay, but you don't find any precipitate also. It is not a clear solution also. We get something called as colloidal suspension or colloidal solution. In this colloidal solution, the soap molecules cluster together to form micelles and remain radially suspended in water. Okay, so as soon as you drop the soap, okay, the particles, we have just seen the structure of the soap, right? These particles arrange together and form many micelles, and these micelles float in the water. Okay, next what happens? The dirt particles always adhere to the oily or greasy layer present on the skin or clothes. Okay, so now you have what you have done. How do you clean your like dresses? What you do? You take a bucket of water. First you add the soap into it, you prepare the solution, and then you add clothes in that, right? So in this solution already the micelles are present. Now the soap is like the clothes are dipped into this. So what will happen? The oil or the dirt particle which is present in the cloth will be attracted towards the hydrophobic part of the micelle. Means which one was the hydrophobic part? One second, this part. Okay, this yellow circle you can see, right? So this oil or dirt will be attracted towards this part. Okay, so what happens here? Okay, next, when a dirty cloth is dipped into the soap solution, its non-polar hydrocarbon end of the micelle gets attached to the grease or oil present in the dirt, and polar end remains towards the water. Okay, so as soon as you drop the cloth, what will these micelles will go, and through their hydrophobic part they get attached to the dirt particles. Okay, next what happens? The mechanical action of rubbing or subsequently dislodges the oil layer from the dirty surface, shaping it into small globules. Okay, so what happens when you do like this? When you rub the clothes, what will happen? These micelle structures are there, right? They will pull out the dirt particle from the cloth and will keep inside them, right? And then when you throw the water, a stable emulsion of oil in water is formed. Okay, now the emulsified oil or grease globules bearing the dirt can now be readily washed with water. So if you just throw the water, that goes away. Okay, so what is the action? First you take a bucket of water, take water in that, and you put the soap in this, right? When you mix the solution, many micelles have been formed in the, can you imagine, just imagine, okay, in the bucket of water you have taken soap solution, you have mixed it well, so many micelles have been formed. Now you are dipping your cloth where there is a dirt particle. What will this do? These micelle particles will go towards the dirt particles and will attach to that. Now when you rub that, what will happen? These micelle particles will pull the dirt out, right? Will pull the dirt out and form globules in the water. Globule means spherical shape, right? So these micelles, inside that there will be the dirt particles. Now if you throw the water, the dirt particles will also go away, right? That is the mechanism. Then what are the disadvantages of using a soap? Now when soap is used for washing clothes with hard water, it forms scum, okay. Now what is hard water? Hard water are those where you have the salts of calcium carbonate and magnesium carbonate, okay. If you have the salt of calcium carbonate and magnesium carbonate in water, we call it hard water. So generally we get some precipitate form if we use soap with that. Now what is the reason for that? This is caused by the reaction of soap with the calcium and the magnesium salts, which causes the hardness of water, okay. Now if you remember, we have the soap structure like this, right? C17H35 CO minus and you have Na plus, okay. Now when you have any calcium 2 plus ions present in the water, right, what will do? This calcium 2 plus will replace the sodium and you get like this. Okay, so like this calcium salts are formed and these calcium salts are insoluble in water and they form scum, okay. So hence we need to use a larger amount of soap. So you have to use more amount of soap to clean the same amount of dirt. This problem is overcome by using the detergents, okay. So now you understood why we need detergents. We'll understand how detergents work now, okay. So detergents are the class of compounds which have also the cleansing action, okay. Detergents are generally sodium salts of sulfonic acids or ammonium salts with chlorides or bromide ions, okay. So detergents are what? In the chain of detergents, okay. In this part you have what? Sulfonic acid, sorry, not like this. If you see soap, it is like this, right? Carboxylic acid salts are there. But in case of detergents, what we have? We have sulfonic acids, okay. You have salts of sulfonic acids or ammonium salts, means you have like this. Ammonium salts are present, okay. Or you can even have chloride or bromide ions, okay. These are not carboxylic acid, these are sulfonic acids. Now, so what is the advantage of that? Now see, both have long hydrocarbon chain. The charged end of these compounds do not form insoluble precipitate with calcium and magnesium ions in the hard water, okay. So the in case of detergent, because of presence of sulfonic acid, they do not form any precipitate with magnesium or calcium salt, right. So that is why they do not form any scum with these type of salts and we can use detergents in case of hard water even, okay. So next, so they remain unaffected and so they remain effective in case of hard water, okay. Now there are some detergents are usually used to make shampoo and products for cleansing clothes, okay. Next, but detergents also have some what I can say disadvantages. The first is they are non-biodegradable, okay. Soaps are biodegradable because they have carboxylic acids, but sulfonic acids are generally non-biodegradable and they can cause pollution. In soil, the presence of detergents leads to the pH change, making the soil infertile, okay. So what happens when we wash in river, okay, and in normal open water bodies, these water comes out and reaches the soil, and because of these components present in the detergents, they affect the pH of the soil which is required for the growth of the plant, okay. Now the pH is changed, so the growth of the plant is also affected and this causes soil pollution. Next is the entry of detergents into food chain leads to bioaccumulation in living beings and lead to serious health issues. Now what happens, that chemicals you have, like for example, somewhere you in the water body you have used the detergents, right? Those water flows to the soil. Now soil takes those type of water and the plants are grown in that, right? Now the component which was there in the detergent has come inside the plant. Now human takes these plant products, right? So it also comes to the human body, right? And it accumulates in the human body, which may even lead to very severe diseases, right? So that is why it is always advisable not to wash clothes and all in open water bodies. Okay. So students, that's all in this class. So I have already explained you what is DSAT all about. If you are interested, please do not delay, go to the description section, click on the registration link and register for DSAT today itself. Okay, that's all in this class, friends. And as I told you, please let us know how was the class and what did you feel, what things you need to be explained and all. But remember, stay tuned for tomorrow's class. We are going to solve previous year questions and many important questions we are going to solve tomorrow. So just watch these 2 videos, revise the chapter and come to tomorrow's class and attend all the questions. Okay, thank you students, that's all in this session. Let's see you soon in the next class.